assignment 6.8, we continue to work on the free response questions from 2013. So again, pause if you have not read the problem a couple of times. There will definitely be a question you'll have to answer this year that uses a data table. So here's the typical example. So we've got a function c of t that produces the amount in ounces of coffee in a cup at time t. And our domain here is 0 through 6 minutes. So in question A, it says use the data in the table to approximate a derivative. Well, we can't do an algebraic derivative, so all we can do is use the slope of a secant to approximate it. So 3.5, the best we can do is use these two data points at 3 and 4. So you want to label your work here that the derivative of 3.5 is not exactly equal to this. We don't know exactly the derivative, but it is going to be somewhere in the neighborhood excuse me, of the slope between these 2 points. So our y2 minus y1 over x2 minus x1. So we're going to take these values, 12.8 minus 11.2, and we will come up with 1.6 ounces per minute. All right, and when they say show the computation, that's exactly what they mean here, is to show that you're doing a slope between 2 points. All right, and then for part B, we are to show that there is a time between 2 and 4 minutes at which C prime will be equal to 2. Well, we can't find exactly when it is, so can you guess that if we're looking for evidence that the derivative equals a certain value, that this could be an MVT question? So remember, what we're trying to show here is that for some function, if we can find that the slope of the secant is equal to 2, if the slope of the secant is equal to 2, then there has to be some place where the slope of the derivative is equal to 2. So we need to write our MVT argument. You may assume that they give you these endpoints for a reason. So let's find out what the slope of the secant would be, and then we'll know whether it's going to work for us. So if we wrote C of 4 minus C of 2, let's find out what the slope of this secant would be here, and find out if they gave us a good hint. So reading from the table, we have 12.8 minus 8.8 divided by 2. And sure enough, that's equal to 2. So they've given us an interval where the slope of the secant is equal to 2. So all we have to do now is mention that we can use MVT because of the hypothesis has to be satisfied first. Well, what did we know here? We knew that C was differentiable. Given C is differentiable, and continuous, and thus continuous, which I don't know if they would expect that you write both. I think that's not really necessary, by the mean value theorem. And if you're short for time, I think MVT would be okay. There is at least, and there's not, again, there's no one particular sentence you have to write here, just get it all in somehow or other. There is at least one C somewhere in the interval we're working in. Remember, that was 2 to 4. Oh, and I guess I don't want to use C here. That's the name of our function. I think let's use time t here. If I can get an eraser. I'm just switching my variable here. So sometime between 2 and 4, such that C prime of t will be equal to 2. And I know that's because I've already done the secant up in my first line. So I think I've shown the hypothesis is true. I've mentioned the mean value theorem. I've shown the interval at which it occurs. Someplace the slope of the tangent is equal to the slope of a secant. So the instantaneous rate has to match the average rate, is again another way of saying that. All right, let's look at part C. Use the midpoint sum with 3 subintervals of equal length in the data table to approximate 1/6 of the integral from 0 to 6. So when you see this, do you see F average? If you take the area from 0 to 6 and you divide it by 6, do you see that you're finding the average height? So if we find the average value of function C, that's the average amount of coffee. So that's what they're asking us to explain in the second part of the problem, explain the meaning. So hopefully you won't be fooled by this if you see an integral divided by the width of the interval. That's going to be your average height. All right, let's see how easy they've made this for us. We're going to do 3 equal intervals. So we're going to look at our data table here, and it's nice that we're going from 0 to 6. So think about a graph of a function that goes from 0 to 6. That if we divided it up, whatever the function is, if we divided it 3 ways, you can see that the midpoint values would be right here at 3 and at, oops, sorry, that's not 3, that's 1, and at 3 and at 5. So they've made this nice so that our midpoint values are readable from the table. So think about your Riemann rectangles measuring those heights. You don't need to make this diagram, by the way. Just trying to explain remind you that you already know what midpoint rectangles are. So we're going to use C of 1 as the height of the first rectangle, C of 3 as the height of the second, and C of 5 as the height of the third. So now don't forget the 1/6 here in front of that problem. So for problem C, let me see if I can change colors here. We could say that we're going to approximate what they asked here from 0 to 6, C of t dt. We're going to approximate this with 3 midpoint rectangles. They each have a height of 2, so you could factor that out in front. You could factor that base of 2 out in front, and that would be perfectly fine. So we're multiplying here. I'm making this hard to read. Let's use a dot for multiply. And then our third rectangle has a height of C of 5. And if we're doing this without a calculator, that's where I would bring the 2 out. And then I could just do these 3 values. What are they? 5.3, 11.2, and 13.8. So do some arithmetic there. You can pause if you wish. I think we have 1/6 of 60.6. Or 10.1. And remember, that's the average value of function C. C is measured in ounces of coffee in the cup. All right? And then we were to explain the meaning of that. So that is 10.1 ounces of coffee, or 10.1 ounces is the average amount of coffee in the cup over the interval from 0 through 6. minutes. So making sure you clarify the units. So making sure that you have ounces here and minutes there, so that you're explaining very clearly that it's an average y coordinate. All right, and then let's go grab part D. Not too bad so far. This is another fairly straightforward problem. D says the amount of coffee in the cup is modeled by this algebraic function, so an exponential function. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Well, if B is the formula for the amount of coffee, then we just have to find B prime. So the derivative, B prime, the derivative of the constant will be 0, and the derivative of this constant times e to a glob will be e to the glob times the chain rule on the glob. So a pretty easy derivative, and then we just have to put 5 into it. So let's see what we can write. So the derivative of the first term was 0, and then we're going to keep the negative 16, and then we're going to have the e to the glob, leave that alone, and then we're going to have to multiply by the chain rule on the glob. So let's see if I can get that out of there. So then we're going to multiply by the negative 0.4. So we will come up with a positive 6.4. 4 times 16 is 64. E to the negative 0.4t. And then we have to find out what is that value at 5 minutes. So we would have a 6.4 e to the negative 0.4 times 5. That's going to be a negative 2. So you could either write it as negative 2, or you could put 6.4 over e squared. And that is a rate. So B was in ounces, and we're differentiating here with time as our independent variable. So this would be, not ounces per time, ounces per, our unit of time is minutes, ounces per minute. And that should do it for that problem.